This video is a continuation of our previous video, and we're going to talk about setting up the null and alternative hypotheses. Okay, so in the previous video, we looked at some claims and we converted them into mathematical statements. Now, in this video, we're going to set the null and alternative hypothesis, as I mentioned. But before we do that, we have to actually look at a complement of our claim. And as a reminder, a complement is everything that the claim does not include. So it's not the opposite, but it's everything else, okay? To illustrate what I mean, I'm going to give you this example. If I said I ate none of the candies that I bought, the opposite of that statement would be I ate all of them. But there is a whole range of things in between, such as I ate one candy, I ate two candy, three candy, which were not included in the claim or the opposite, right? So, but remember, the claim and the complement should cover all possibilities. So the complement of the claim is everything else that's not included in the claim, and it should cover all other possibilities. So for the claim a proportion is less than 0.05, what would be the complement? Go ahead, and I want you to answer that question. All right, so here's what the thinking is. If you just say proportion is greater than 0.05, that's gonna be the opposite statement, right? However, we said that the complement should cover all of the possibilities. So these two do not cover one more possibility, which is equals to, right? So for the complement, we're going to say that proportion is greater or equals to 0.05. So in general, we have three possibilities, right? We have the possibility that something is greater than a certain number, something is smaller than a certain number, and something is equals to a certain number. So those three possibilities, they cover the entire range of possibilities, right? Well, we do have kind of like this standalone one, which says not equals to, which means less than or greater than, but I think it's just a variation. So think of three, less than, equals, or greater than. So if we have less than here, then greater and equals should go into the complement. So here we have mean equals to 108. What is not included in here? Well, less than or greater than, not included, right? Which could be combined into mu not equals to. All right. Next claim is that sigma is greater than 1.21. So what's not included in here? And if you said less than or equals to, you were correct. Okay. So now, what's not included here? So mu is not equals to 67,565. So what's the complement? So not equals to covers a less than and the greater than. So what's not included in here is mu equals to 67,565. All right, guys. I hope that you find this clear. And we're going to continue to setting up the null and the alternative hypotheses. So here's the rule about the null and the alternative. So here's some notes or rules about the alternative hypotheses. The aim of the hypothesis testing procedure is to prove the alternative hypotheses. So if you're a scientist and you're setting up your study, you should state your claim so that the claim is your alternative hypothesis, because the alternative hypothesis is stronger statement than the null statement, okay? What does that mean in mathematical terms? In mathematical terms, that means that alternative hypothesis does not have an equal sign. So no equal sign is included in an alternative hypothesis. So let's come here. If we are looking for an alternative hypothesis, what's going to be our alternative hypothesis? The p is less than 0.05, or p is greater or equal to 0.05. Well, like we said, alternative hypothesis doesn't have equal signs, so this goes into the alternative. So an important notion, claim does not always end up in the null hypothesis. So students often have this idea that the claim should end up in the null. It's a wrong impression. So the way we set up the null and alternative hypothesis is that we pick the one with no equal sign into the alternative hypotheses, and the null will just have an equal sign and nothing else. Let me show you what I mean. So here I copied our claim and complements. So let's first, what I would do, I will pick out from these two statements, the one that goes into the alternative hypotheses. It's the easiest one because it shouldn't have the equal sign, right? So between p is less than 0.05 and p is greater or equal to 0.05, this statement has an equal sign. This one doesn't. So it goes into the alternative. P is less than 0.05. Now, out of these two, the statement has equal sign, this one doesn't. Out of these two, this statement doesn't have equal sign. And out of these two, this statement doesn't have an equal sign. So here's what we got. I just wanted to mention that I had to redo it because I accidentally highlighted the wrong hypotheses. But I want to point out that, again, it's very important that when we choose between claim and the complement, which one will go into the alternative hypothesis, we select the one that doesn't have the equal sign. That's the criteria, okay? The claim does not always get into the alternative or the null. As you can tell here, the claim got into the alternative. Here, the claim didn't get in the alternative. Here, the claim got into the alternative, okay? Again, alternative hypothesis is what we will try to prove. So if you're trying to prove something, you want to formulate your statement, your claim, so that it will end up in the alternative hypotheses. Now, what goes into the null? Into the null, we're just gonna say equals, everything equals, right? So P equals to 0.05, mu equals to 108, sigma squared equals to 1.21, and mu again equals to 67.565. Okay, so that's how you set up the null and the alternative hypotheses. Now, a couple of things. The symbol that we use for the null is H with a subscript O. This is hypothesis 0. And for, or the original, the null. And for the alternative, we use H with a subscript A. And that's what we're going to use in this course. But in some books, in some publications, you may see H with a subscript 1. Or this is the null, which is 0. This is the next one, which is 1, right? Or A for the alternative. Okay, so that's the notation. That's what you're going to see when you're doing your homework. Now let's talk about what this is. This is going to be important. Okay, so what again, we are trying to prove the alternative hypotheses. So assuming that the null is true. So let's say I assume that the true rate of people who get sick is 0.05. So again, we're going to be working with normal distribution. So we have to check that our samples satisfy the conditions so that we get a normal distribution for sample proportions in this case. So, and let's say that we assume that this is true. So the population proportion is 0.05. Okay, but we are trying to prove that it's less than that. Okay, so where would we expect our sample proportion to land if we want to prove that the true proportion is less than 0.05? On the left side of the 0.05, on the right side of 0.05, in the middle? What do you think? Let me know. Well, I hope that you said that your test proportion should land on the left side and like right here. Okay, so if it lands like somewhere close here, let's say it lands at 0.049, would that really prove that it's really that the true proportion is really smaller than 0.05? Not really, right? Because even though it landed on the left, but very close. We need, in order for our proof to be, for our evidence to be a strong evidence, we need the test proportion to land like far on the left side, which it should be a rare value. In other words, it should be a rare value. If this is true, then the value that we get should be a rare value in order for us to basically disprove the null hypotheses, right? And so since our test statistics we expect it to fall on the left side, we're going to call it a left tail test. Okay, this is a left tail test. Now I'm going to skip this for now. I'm going to let's take a look at our sigma. Well, sigma squared is not a normal distribution, so we're not going to draw a normal distribution, but still we're trying to prove, we're assuming that the sigma squared is 1.21. Okay, so 1.21, that's our assumption that the null is true, and we're trying to prove that sigma squared is greater than that. Well, if it's greater than that, do we expect it to fall on the left side or on the right side or in the middle? Well, it's never in the middle, okay? So either on the left or on the right. Well, you should go with your sign. Look at where the sign is pointing, right? So if we have a greater sign, that means it points to the right side. So your value from the test, from the sample, should land on the right-hand side, far away on the right side. So this is going to be a right tail test. Okay, now what about here? So again, the assumption is that, my picture, I don't have enough room. So the assumption is this: mean is 108. That's the assumption. We're trying to prove that it's not equals. And remember, we mentioned that not equals means that it could be smaller than or it could be greater than. So our test sample statistic could fall either on the left side or on the right side. Either or, that would prove mean not equals to 108. So this is a two-tail test. Two-tail test. Okay, and the same thing is here. We're trying to prove that mean does not equal to 67,565, even though the null hypothesis tells us it is. We're trying to prove that it's not. So again, it could be on the left side or on the right side of that claimed value. If our test from the sample statistic will fall either on the left side or on the right side of this value, like way in the tail area, right? In the unusual values region, then this is going to prove the alternative, and it's going to be a two-tail test. And by the way, we call these regions critical regions, right? So critical regions. This is the value. This is the region where all the unusual values are located. And the test statistic here, not the test statistic, sorry, the critical value would be the value that separates those unusual values. So this is going to be your critical value, and you're going to find it similar to how you found your critical values in Unit 10. So a critical region will be separated by critical value. I believe I have it as CV for short. And just like in Unit 10, remember, you used the normal distribution, the standard normal distribution, Z, for proportions. You used student T distributions for the confidence intervals of the mean, and you use the chi-square distribution for the confidence intervals for variance. So we're going to follow that same pattern here for finding the critical values or the p-values for hypothesis testing as well. So once we set up the null and alternative hypotheses and decided whether our test is going to be the left tail, right tail, or two-tail, the next step would be to actually look at a sample, collect a sample from the population, and look at the sample statistic. and see if we will get an unusually high or unusually low results for the assumed null hypotheses. And we're gonna address it in the next video.